Well, hello, Year 10s, once again, and welcome to your third and exciting installment of Things You Can Do with Pythagoras. Today we're going to be having a look at how you apply the Pythagorean theorem. So that means we're not just going to be dealing with triangles on a page, we're actually going to try and solve some problems. Okay, firstly, a few definitions. Trees, buildings, hills, people, masts, all that kind of thing are generally vertical. So vertical means up and down, okay? All right, if you've got the ground, the sea, or the base of anything, generally that means it's horizontal. Okay, so that's this way here. And if you have things that lean or tie down, they tend to be the diagonal, okay, and that is the hypotenuse. Just tell my phone to shut up. Sorry about that. It's very bad. Okay, good. All right. There we go. Okay, now it'll be shushed. All right, so when you're actually solving a problem using Pythagoras, you need to first read the question. Sounds really obvious, right? But a number of people just don't read it. Then you want to draw a picture. Now, we all know that I am a very, very gifted artist. You don't need to be. All you have to do is really represent that information on a triangle. And as you know, even I can draw a right-angled triangle, so it's not really a problem. Once you've drawn your triangle, you need to find and label any sides or measurements that you've got, and then decide if you're finding the short side or that stretched hypotenuse. Generally, if something's on a lean, then you're going to be going for the hypotenuse. Then you solve the problem using good working, of course, and we're all sorted with that. And then don't forget to answer the problem, because sometimes the problem isn't what measurement, it might be, would it fit? Okay, so let's have a look at a couple of problems. Okay, so we've got a 15-foot ladder leans up against a building. The foot of the ladder is 5 feet from the base of the building. Crazy. How high up the wall to the nearest foot does the ladder reach? Now, I know this is in feet, and that's a bit annoying, but we're just going to, in our head, pretend it's in meters, because they work the same way in maths. Okay, so here we go. We're going to draw that picture. There she is. There's the triangle. Now, if you're having a look at this piece here, this is the building because it's vertical. And we've got a ladder, and ladders generally lean, so that's the ladder because it's leaning up against the building. And this is the base of the building along here, okay? Awesome. So there's the measurement. We know it's a 15-foot ladder. We know it's 5 meters from the base. The question is, how high up does it reach? So we're looking for that X measurement right now. Okay, so let's solve it. First of all, you need to write the formula. Now, we've talked about this before. Not your formula. It belongs to Pythagoras, so write it down, please. Then you're going to substitute in your values. So you'll see that I knew I had the hypotenuse and I short side, so I've put those in. And then I'm going to solve it for X. So just like we did today, and I'm going to get the answer. Okay, so how do I need to leave my answer? Well, I don't just leave it like that because it was actually a word problem. So I'm actually going to answer that that actually reaches 14 feet up the wall. Okay, so if you think back to that original triangle, what we're saying is this. We knew this was 15, we knew this is 5, and up the wall it's 14. Okay. Right, let's try a second one here. Tim, for want of a better name, because it's nice and short, rode 8 kilometers due north. Now, due north means this. Okay. Then he drove. Then he went 3 kilometers due east. Now, east is this way here. And it said, how far to the nearest kilometer is Tim from where he started? Okay. Oh, actually, I've drawn the diagram wrong, and I'm just going to correct it for you. Oh, look, there's an erase function. Isn't that good? Okay, so what happened is, let's start Tim off. Tim went 8 kilometers due north, and then he went 3 kilometers due east. See the triangle there? Now, if you finish off this triangle, this is actually the distance we're trying to find, and here is the right angle. So bad me for not reading it properly in the first place. Okay, so we draw a picture. Oh, there's the real triangle. Here's the 8. There's the 3. We're looking for that. Let's go to it. Okay, so again, there's the old equation. And I've filled in the information. This time, if you go think about it, we were looking for the hypotenuse. So I've put the two short sides in. And just solving it. Remember this line here I don't need. Okay, so I can go direct to this one here. And remember how you're supposed to leave your answer. It should be, the answer was, that should be H, by the way, sorry about that. 8.544, but that's not all that useful because it said to the nearest kilometre. So Tim's actually 9, bad Miss Wilson, 9 kilometres from where he started. Now it's 9 because I was asked to leave it to the nearest whole kilometre. And if you have a look at 8.5, that actually rounds up to 9, not 8. Thank you very much. Okay, so let's just wrap this up with a few thoughts. First of all, the Pythagorean theorem can only be used on what kind of triangles? And when should the Pythagorean theorem be used? And what should be done first when solving a word problem involving the Pythagorean theorem? You've got the answers in your head? Let's check them out. Oh, one more. What must be done before writing an answer to the Pythagorean theorem? Okay. All right. Okay, first of all, I have to use them on right-angled triangles. You use the Pythagorean theorem when you know two sides and you want the third side. You've got to draw and label a triangle if you're solving a word problem. And you should check and see the final thing whether your answer should be